Learning goal number 10, ordering rational numbers. Okay, today we're going to be focusing on ordering rational numbers, so taking basically fractions and decimals and integers and putting them in order from least to greatest. So let's take a look at an example problem right away. Okay, here we go. We got four numbers, 1/5, -0.7, 0.25, and -3/5. So you can start to characterize these based off of just if they're positive or negative right now. But what we actually need to do is we actually need to have them all in fraction form or all in decimal form. I would prefer in this case changing them to decimal form. If you have all fractions, then change them to fraction form by coming up with a common denominator. But if not, I would go with decimal form. It's probably the easier conversion. So for example, 1/5. You want to figure out how many times 5 goes into 1. Okay, 5 goes into 1, 0. 5 goes into 10 twice, and it goes in there exactly. So 1/5 is 0.2. All right, we have that number. -0.7, it's already in decimal form. And also 0.25 is already in decimal form. So that's good. Those three are good to work with. Let's focus on the -3/5. Okay, we want to figure out how many times 5 is going to go into 3. 5 goes into 3 0 times. 5 goes into 30 6 times. And it's exact. You end up with a remainder of 0. So that's -0.6. Okay, so now I have four numbers. I want to rank them from smallest to largest. So if you imagine a number line, all of these numbers fall between -1 and +1. So just real quick, if I think of a number line, okay, 0.2 is going to be up here. That's 0.2. -0.7, that's going to be closer to 1 here. 0.25 is going to be a little bit more than 0.2. And -0.6 is going to be close to 1, but not as close as -0.7. All right, so it's a little bit trying to throw you off there a little bit. Again, as I move further towards 1, the decimals are going to increase closer to 1. So -0.7 is actually our smallest number. And then -0.6 is our next smallest number. And then 0.2, 0.2, all right? And then finally 0.25. That's from least to greatest. Again, write them all as decimals first and then compare them. Write them all as decimals first and then compare them. Let's take a look at another example right now. Okay, so in this next example, what we're going to do here is we're just comparing two numbers. So in the previous example, we were comparing four numbers, least to greatest. Here, we just want to identify if they're going to be this is going to be less than that, greater than, or equal to. So here's what we need to do. If they're all in fraction form, work with fraction form, right? So to be able to compare these in fraction form, we want the same denominator. So for example, 7/10, right? That has a denominator of 10. 4/5 has a denominator of 5, but I can easily make that have a denominator of 10 if I multiply the bottom by 2 and the top by 2. So 3 and 4/5, that's the same thing as 3 and 8/10. And then 3 and 7/10, just leave that as is. So if I'm looking at this, they are both in between 3 and 4, right? Pretty simple. 7/10 and 8/10. Well, 8/10 is a bigger value, right? So 7/10 is less than that. So 3 and 7/10 will be less than 3 and 8/10. Now, if you don't feel comfortable working with mixed numbers, you could change them to improper fractions. 10 times 3 is 30, plus 7 is 37 over 10. Over here, 10 times 3 is 30, plus 8 is 38 over 10. Still, 37 over 10 and 38 over 10, that'd be less than each other. That'd still be less than. Again, you could also change these to decimals. So 7 over 10, if you figure out how many times 10 goes into 7, it's actually 0.7, so that's 3.7. And then if you change this to a decimal, right, 8 over 10, 10 goes into 8.8 times. You still get 3.8. 3.8 is still the greater value, or 3.7 is still the less value. So either way you look at it, if you convert them to mixed numbers with the same denominators, like I did in the first place, less than. If I change them to improper fractions, this value is still less than. Or if I change them strictly to decimals, this is still less than. What you need to do to be able to compare rational numbers is either to get them all in the same format, either be fractions or decimals, probably decimals being the easiest, that's kind of easy in this case, and then compare them that way. That's all I got for you here. Why don't you try a few problems on your own right now.
Turn down for what?